This lesson is going to be a bit long because if you take a look at the screen, we are having a long span beam that has one pin support at point A and 3 roller supports, one at point B, one at point E, and one at point F. So we are going to have 5 unknown reactions. Now, I know you might be thinking that this is going to be a statically indeterminate structure, but because we have 2 hinges, as you can see, we have one hinge at point C and we have another hinge at point D. So this is going to reduce the degree of indeterminacy from 5 to 3. So these hinges, they are going to make this beam a statically determinate beam. Now, what we're going to do is we are going to assume the direction of this support reaction. We are going to say all the vertical forces is acting upward, while all the horizontal forces is acting to the right. So at point A, we are going to have AY, this is acting upward. Then we are going to have AS, this is acting to the right. Then at point B, because it is the roller support, we are going to have just one support reaction. So this is BY acting upward. At point E, we are going to have EY acting upward. Then at point F, we are going to have FY acting upward. So these are the support reactions we need to calculate. Now you need to know that AS is going to be automatically equal to 0 because we don't have any horizontal force on this beam. So we're going to say AS is automatically equal to 0 because we don't have any horizontal force on this beam. So we need to calculate the remaining support reactions. Now, how can we calculate the support reactions? Now, we are having a distributed load of 2 kip per foot that is applied on this beam. If we try to use summation of moments at any point, or maybe we try to say all the vertical forces acting upward is 0, we won't be able to calculate these forces because they are too much. We have AY, BY, EY, and FY. So we need to use another method, or we need to use another way to calculate these support reactions. Now, how can we calculate this? This is the reason we have hinge on this beam. So we are going to use this hinge to evaluate these support reactions. Now, we are going to make a section, or we are going to cut a section at the hinge. So we are going to cut a section either at D or C. Now, if you cut a section at point D and you look to the right, we are still going to have 2 unknown forces. We are going to have EY, FY, and we're also going to have an unknown internal forces. So we are going to have an unknown vertical force, unknown horizontal force, and unknown bending moment. So we won't be able to calculate this if we look at the right. Also, if you look at the left, we won't be able to calculate AY and BY because we're also going to have unknown internal forces. Now, what do we need to do? What we need to do is we need to make a segment, or we need to make a section at point C and D. So we're going to make a section at point C. We're also going to make a section at point D. So we're going to evaluate this section. So we're going to evaluate CD. Then we are going to calculate the internal forces inside the beam. So let's calculate this. So if we make a section at point C and D, we are going to have something like this. So this is point C and this is point D. So we know we are having a distributed load. We are having a distributed load of 2 kip per foot. So this is distributed load 2 kip per foot. Now we need to resolve this as point load, and we know the distance. This distance is 120 feet. So this is 120 feet. So we need to resolve this as a point load. How can we resolve this? We are going to take the area of this rectangle. So it's going to be 2 multiply 120. So this is going to give us 240. So this is going to give us 240. So the point load is going to give us 240 kip. And this is going to be at the middle. So we are going to have this as the middle. So we are going to have 60. So this is going to be 60 feet. Then we know we're also having 100 kip. As you can see, we're also having 100 kip applied on the beam. So we're having 100 kip here. So this is 100 kip. And this 100 kip, this is located 30 feet from point C. So this distance is 30 feet. So now we are also going to have unknown internal forces on this beam because we made a section at point C and point D. So we are going to have an unknown vertical force CY because we don't have any horizontal force on this beam. So the unknown horizontal force or the unknown internal horizontal force is going to be equal to 0. Also, we know that moment at hinge is equal to 0, so we don't have any moment. So at point D, we're also going to have dy. This is starting upward. So we're going to calculate cy and dy. Now, how can we calculate this? We are going to take the summation of moments at any point. Let's take the summation of moment at point C. So we're going to say summation of moments at point C is equals to 0. We're going to assume all the movement in the counterclockwise direction to be positive, while all the movement in the clockwise direction to be negative. So if we apply 100 kip on this beam with relative to point C, it is going to try to rotate this beam in the clockwise direction. So this is going to be negative. So this is negative 100 kip, then multiply by the distance. What is the distance? As you can see, the distance is 30 feet. So this is going to be multiplied by 30 feet. Then also we are having 240 kip, and this is acting downward. So if we apply 240 kip on this beam with relative to the point C, it's going to try to rotate this beam in the clockwise direction. So this is negative. So this is negative 240 kip, then multiply by the distance. So what is the distance? The distance is 60 feet, as you can see. So this is going to be multiplied by 60 feet. Then what about dy? Dy is acting upward. So if you apply this force on this beam with relative to point C, it's going to try to rotate this beam in the counterclockwise direction. So this is going to be positive. So this is positive dy, then multiply by, what is the distance? The distance is 120 feet, as you can see. So this is going to be multiplied by 120 feet. So because we don't have any additional force, this is equal to 0. So if you calculate dy, you are going to get dy is equal to 145 kip. So dy is equal to 145 kip. Now, because we're having a positive value, meaning this is acting upward because we're having a positive value. So what we need to do, we need to find cy. How can we calculate cy? We just need to take the summation of the forces in the vertical direction equal to 0. So I'm going to say summation of the forces in the vertical direction is equal to 0. I'm going to say all the forces acting upward is positive, while all the forces acting downward is negative. As you can see, cy is upward, so this is going to be positive. So this is going to be cy. Then 100 kip, this is acting downward, so this is going to be negative. So this is negative 100 kip. Then 240 kip, this is acting downward, so this is also going to be negative. So this is negative 240 kip. Then we are having dy. Dy is 145 kip, and this is acting upward, so this is going to be positive. So this is positive 145 kip. So because we don't have any additional force, this is equal to 0. So all we need to do, we just need to calculate for cy. Now if you calculate cy using your calculator, you're going to get cy is equal to 195 kip. So cy is equal to 195 kip. And as you can see, this is a positive value, so meaning this is acting upward. So these are the internal forces. Now, what you need to do is you now need to look at either segment ABC or segment DEF. Now, we already know the internal forces. You need to know that these internal forces, these are not the support reaction. These are not included in the structure. We calculated for this because we want to calculate for the support reaction, because if we don't know the internal forces, we won't be able to calculate for this support reaction. So this is the reason we calculated for the internal forces. Now we know the internal forces, we are now going to use this to calculate the support reaction. So what we are going to do now is we are going to take a look at segment ABC. Now we know the internal force. We're now going to take a look at segment ABC so that we can calculate BY and AY. So we're going to say take a look at segment ABC, or I'm going to say make a section at point C and look to the left. So I'm going to write this as segment ABC. Now, segment ABC, if you take a look at this, we are going to have something like this. So this is the pin support, and we are having AY. This is acting upward, and we know AS is equal to 0. So we are having a roller support at point B. So this is BY acting upward. Then this is the distributed load. So this is the distributed. So this is the distributed load, and the distributed load is 2 kip per feet. 2 kip per feet. Now this is the point. Now this is the point C, as you can see. So we need to resolve this distributed load as point load. How can we do this? We just need to take the area, and we know this distance. This distance is basically 100 plus 90, which is going to give us 190 feet. And we know this is from A to B. This is 100 feet. This is 100 feet. Then from B to the point C, this is 90 feet. This is 90 feet. So 2 multiply 190, this is going to give us 2 multiply 190, this is going to give us 380. So the resultant force is going to be 380 kip. So this is 380 kip, and this is going to act at the middle. So we are going to have this as 95 feet because it is acting at the middle. Now all we need to do, we just need to calculate for AY and BY. And you need to know that because we calculated CY, which is internal force, we calculated CY to be 195 kip. Now if we take a look at segment ABC, this is going to act downward because to the right of ABC, this is acting upward, as you can see. So to the left of ABC, it is going to act downward in order for us to satisfy equilibrium, because when we calculated for CY using CD, we got 195 kip, and this is acting upward. Now looking at segment ABC, this is going to act downward so that equilibrium can be satisfied. So this is going to be 195 kip. So this is going to be 195 kip, and this is acting downward because the forces are same, but they are in opposite direction. So what we need to do, we just need to calculate for AY and BY. So we are going to say summation of the moment at point A is equal to 0. So let's take moment at point A equal to 0 so that we can calculate for BY. So I'm going to say summation of moments at point A is equal to 0. And I'm going to take all the movements in the counterclockwise direction to be positive, while the movement in the clockwise direction to be negative. So this is going to be 380 kip. If we apply 380 kip on this beam, and this is acting downward with relative to point A, it is going to try to rotate this beam in the clockwise direction. So this is going to be negative. So this is negative 380 kip. Then multiply by the distance. What is the distance? The distance is 95 feet, as you can see. So this is going to be multiplied by 95 feet. Then we have BY. BY is acting upward. If you apply this on this beam with relative to point A, it is going to try to rotate this beam in the counterclockwise direction. So this is going to be positive. So this is positive BY. Then multiply by the distance. What is the distance? The distance is going to be 100 feet. As you can see, this is 100 feet from point A. So this is going to be multiplied by 100 feet. Then we have 195 kip, and this is acting downward. This is going to try to rotate the beam in the clockwise direction. So this is going to be negative. So this is negative 195 kip. Then multiply by the distance. So what is the distance? The distance is going to be 100 feet plus 90 feet, which is going to give us 190 feet. So this is multiplied by 190 feet. So we don't have any additional force. So this is equal to 0. So all we need to do, we just need to calculate for BY. So if you use your calculator, you're going to get by is equal to 731.5 kip. So by is equal to 731.5 kip. As you can see, this is a positive value, so meaning our assumption is correct. This is indeed acting upward. So we're going to take summation of all the vertical forces equal to 0. So we're going to say summation of all the vertical forces is equal to 0, and we're going to say all the forces acting upward is positive, while all the forces acting downward is negative. So what is AY? We don't know AY. This is what we want to calculate. So this is AY, and this is positive because it is acting upward. We're having 380 kip. This is going to be negative because it is acting downward. So this is 380 kip. Then we are having by. We calculated by to be 731.5 kip, and this was acting upward. So this is going to be positive. So this is positive 731.5 kip. Then we have 195 kip, and this is acting downward. So this is going to be 1 minus 195 kip. So we don't have any additional force, so this is equal to 0. So all we need to do, we just need to calculate for AY using our calculator. So AY is going to be equal to negative 156.5 kip. So this is the value of AY. As you can see, we are having a negative value. Because we are having a negative value, our assumption is wrong. This is acting downward because we're having a negative value. Now we know the value of AY, we know the value of BY, and we know AS. AS is equals to 0. So we are left with just EY and FY. So how can we calculate for EY and FY? So what we are going to do is we are going to take a look at this other segment. We are going to take a look at segment DEF because we want to calculate for EY and FY. So let's take a look at this segment. Now, if you take a look at segment DEF, we are going to have something like this. So we're having a pin support at point, we're having a roller support at point A. Then we're having another roller support at point F. So this is EF acting upward. This is FY acting upward. Then this is the hinge at point D. So we also have a distributed load of 2 kip per feet. So this is a distributed load of 2 kip per feet. Now we know this distance is the distance from point D to E. This is 90 feet, as you can see. Then the distance from point E to point F, this is 100 feet. Yeah, this is 100 feet. So we need to resolve these 2 kip. We need to resolve this distributed load of 2 kip per feet. We need to resolve this as a point load. So we're going to take the area of the rectangle. So this is going to be 2 multiply 190. So 2 multiply 190, this is going to give us 380. So this is going to be 380 kip. So we're going to have 380 kip, and this is going to act at the middle of the rectangle. So we know we are going to have an unknown internal force, and we calculated for this unknown internal force, which was dy. We calculated this value to be 145 kip, and this was acting upward. Because we are taking a look at DEF, this is going to act downward because the forces are similar, the forces are same, but they are opposite. Because we need this value to be opposite so that our beam is going to be at equilibrium. That is, the internal forces is going to be at equilibrium. So because the value is 145 kip and it is acting upward, and we want to take a look at DEF, this is going to act downward in order for this beam to, or in order for the internal forces to be at equilibrium. So this is going to be 145, if I'm right. Yeah, 145 kip. So this is 145 kip, and this is acting downward. So what we need to do, we just need to calculate EY and FY. Let's take summation of moments at point F so that we can calculate EY. So this is going to be summation of moments at point F is equal to 0. And we're going to say all the movements in the counterclockwise direction is positive, while all the movement in the clockwise direction is negative. So as you can see, we're having 145 keep, and this is starting downward. If we apply this on this beam with relative to point F, it's going to try to rotate this beam in the counterclockwise direction. So we're going to have a positive value. So this is going to be 145, then multiply by the distance. The distance is going to be 190 feet, as you can see. So this is going to be 190 feet. Then we have EY, and EY, this is acting upward. If we apply this on this beam with relative to point F, it's going to try to rotate this beam in the clockwise direction. So this is going to be negative. So this is EY, then multiply by the distance. So what is the distance? The distance is going to be 100 feet, as you can see. This is from EY to point F. So this is going to be 100 feet. So this is multiplied by 100 feet. Then we have 380 keep, and this is acting downward. If we apply this on this beam with relative to point F, it is going to try to rotate this beam in a counterclockwise direction. So we're going to have a positive value. So this is positive 380 keep. So we also need the distance because moment is equals to force times distance. So what is it? What is the distance? The distance is going to be 95 keep because this is at the middle of the rectangle. So it is going to be 95 keep. So this is multiply by 95 feet, not keep. I'm sorry for that. This is 95 feet because this is a distance. So it's going to be in feet. So this is multiplied by 95 feet. Then we don't have any additional force. So this is equal to 0. So all you need to do, you just need to use your calculator to calculate for EY. It is very easy now. Just use your calculator to calculate for EY. So if you calculate for EY, you're going to get EY is equal to 636.5 keep. So this is going to be the value of EY. So EY is 636.5 keep. Now, as you can see, this is a positive value, so meaning this is acting upward. Our assumption is correct. Now, we are left with just Fy, so we're going to calculate Fy. Now, how can we calculate Fy? We are going to take the summation of all the vertical forces equal to 0. And we're going to say all the vertical force acting upward is positive, while all the vertical forces acting downward is negative. So this is going to be 145 keep is acting downward, so this is going to be negative. So this is negative 145 keep. Then we're having 380 keep. 380 keep is acting downward, so this is going to be negative. So this is negative 380 keep. Then we have EY, and we calculated EY to be 636.5 keep, and it was acting upward. So this is going to be positive because it is acting upward. So this is positive 636.5 keep. Then we are left with Fy. This is what we want to calculate, and this is acting upward, so this is going to be positive. So this is positive Fy. We don't have any additional vertical force, so this is equal to 0. So all you need to do, you just need to calculate Fy. If you calculate Fy, you're going to get Fy is equal to negative 111.5 keep. So this is going to be the value of Fy. As you can see, we are having a negative value. So because we're having a negative value, our assumption is wrong. This force is acting downward. So these are the forces. So these are the support reactions. Now we need to write a summary of these support reactions. So let's quickly write a summary. So we're going to say summary. Now the first force AS, this is equal to 0 because we don't have any horizontal force on this beam. And AY, we calculated AY as 156.5 keep, and this was acting downward. Then we calculated BY as 731.5 keep, and this was acting upward. Also, we calculated EY as 636.5 kip, and this was acting upward. Then lastly, we calculated FY as 111.5 kip, and this was acting downward. So these are the support reactions that are going to keep this structure at equilibrium. So these support reactions, this is what we need in order for this beam to be at equilibrium. Now, if you want to make a quick check, let's say you want to check if your answer is correct or not, what you're going to do is you are going to take the summation of all the vertical forces need to be equal to 0, or the summation of all the horizontal forces need to be equal to 0, or summation of all the moments needs to be equal to 0. Now, if you can prove this, meaning your answer is correct, meaning your calculations is correct. So let's quickly make a quick check. So let's take all the forces, that is all the vertical forces. Let's say this is equal to 0. So let's try to prove that this is indeed equal to 0 by taking all the vertical forces equal to 0. So if we can get all the vertical forces equal to 0, meaning our calculation is correct. So what you need to do is you need to decompose, or you need to resolve these 2 kip per foot as a point load. Now, how can we do this? This is a big rectangle, as you can see. So this is going to be 2, which is the weight, then multiply by the length. Now, what is the length? The length is going to be this distance. So this is going to be 100. This is 100 plus 90 plus 120 plus 90 plus 100. Now, if you calculate this, you are going to get 500. So 500 multiplied 2, this is going to give us 1000. So we are going to have a point load of 1000 kip, and this is acting at the middle. So let's calculate this. Let's see if we are going to get 0 or not. So I'm going to say summation of all the vertical forces needs to be equal to 0, and all the vertical forces acting upward is positive, while all the horizontal forces, while all the vertical forces acting downward is negative. Pardon me. So we are going to say the first force we have, that is the first vertical force we have, is 156.5 kip. This is acting downward, so this is negative. So this is negative 156.5 kip. Then the next vertical force we have is BY, and BY is 731.5 kip. This is acting upward, so this is positive. So this is positive 731.5 kip. Then the next vertical force we have is 100 kip. This is acting downward, so this is negative. So this is negative 100 kip. Then the next force we have is 1000 kip. This is acting downward, so this is negative. So this is negative 1000 kip. Then the next force we have is EY. As you can see, EY is acting upward, so this is going to be positive. So this is positive 636.5 kip. And now lastly, we have FY, which is 111.5 kip, and this is acting downward, so this is negative. So this is negative 111.5 kip. Now, this needs to be equal to 0. If it is equal to 0, our calculation is correct. But if it is not equal to 0, our calculation is wrong. So let's quickly calculate this. 156.5 plus 73.5 minus 100 minus 1000 plus 636.5 minus 111.5. Indeed, this is going to be equal to 0. As you can see, this is equal to 0, so meaning our calculation is correct. Because if you think of it, we always want our structure to be at equilibrium. We want this beam to be at equilibrium. How can we make this beam to be at equilibrium? We need the support reactions, we need the vertical support reactions to balance the force, that is the forces that are applied on the beam. So we need the support reactions to counteract these forces. Now, if we have the final answer to be 0, meaning the support reactions is in equilibrium with the applied load that is applied on the beam. But if we have a different value, meaning this beam is not at equilibrium, because in order for this beam to be at equilibrium, the support reaction needs to counteract the applied load. So this is the reason we always want our value to be 0, because this means our structure is at equilibrium. So this is the final answer.